Hi everyone, welcome back to another video. So if you don't know already, this is a continuation of my final year project, which is for me to develop a very small renewable energy kit that I can hopefully sell on Amazon and the rest of the internet after I graduate from university. So the final year project is going to be a solar panel. So you get power from the solar panel, which goes into a charge controller, which then is stored in a battery. And then from that battery, you have a DC output, which is used to charge, or used to power a Raspberry Pi or an Arduino, or both maybe. And then it also produces an AC output. And the point of the kit is that a student or a hobbyist could use that kit to then build that project circuit that I just mentioned there, which is the solar panel to the battery to the Raspberry Pi or the Arduino, and then also the AC output. And then what they can do is they can follow the tutorials that I create, both in PDF and in video format, in terms of them actually physically building the circuits themselves on the perf board. So that's the plan of the final year project. I'll link a video to the whole in-depth plan of the project up in the top right, so you can click that. And then what we're going to do now is we're at the stage in my learning phase where I'm just trying to learn how all of this works. And so if you watch the previous videos, then you know that I don't have a clue what I'm doing, and I'm learning on the job, or I don't have a job, but I'm learning in the process of it. So I actually start my final year in October, or beginning of October, end of September. So I've still got a couple of months. So I'm just trying to learn as much as I can in this summer period. So the learning phase that I'm in is broken into three different phases, which is the first stage is that I'm going to build the whole project using commercially available parts, like you can see here. I've gone and bought these parts, and then the plan is to actually use them and create the kit, which is a challenge in and of itself. Then after that, I'm going to go and buy specific DIY kits, which involve me actually soldering and building the kits themselves. And then thirdly, I'm going to go and buy the components and just build and copy the commercial kits basically, and the DIY kits, and make the whole entire project itself like that. Thereafter, when I go into the development phase and the other phases of the project, I'm going to actually physically be designing the schematics myself, my own schematics, using my own components, my own component values. It's going to be deep. This is going to be very deep. So the stage that we're at right now is I've got the solar panel, which is right here. I've got the solar panel working. I've got it going into a charge controller here, and it's charging a battery. So I've got that part of the project working fine. In this video, I want to try and get an AC output. Now, this is going to be tough. Firstly, I'm scared to death of AC, literally. For example, this AC inverter module that I've got here looks very scary. I mean, look at it. That is, scary. And so we've got a whole bunch of different voltages here, and I believe we can get, there we go, we can get 380 volts out of this thing. How does that not scare you? So I don't want to use this, and I hope I don't have to use this. That's my hope. So let's go over what I want to do. I've currently got a 5-volt panel, and those 5 volts are going into this charge controller. This charge controller is then outputting 3.7 volts to charge my LiPo battery. So you can see 3.7 volts going into the battery, and the battery is charging. Cool. So we're all good there. The great thing about this solar charge controller is that you actually get 5 volts out of this USB port, and you also have some pins here that produce 5 volts. So I had these connected to it, but what I'll do is let's turn on my multimeter and show you guys. You can see I got 5.11 volts. Same if I use this ground pin, 5.11 volts. So I've got 5.11 volts coming out of these red pins here. This is great, and it's a steady, if you didn't notice there as well, there's no voltage fluctuations or anything. You've got a steady 5.11 volts. Perfect. And I've checked it multiple times. It's always producing 5.11 volts. So the solar charge controller that I want to build, I'm hoping can be exactly like this. This is perfect. So now what I'm thinking of doing is I've got this inverter module here, which actually takes in 12 volts at its input, and it produces an AC output. Okay, so I've checked the description, and sadly it seems like this is not what I'm after. So this needs 12 volts DC, which I was thinking that I could use a boost converter to boost the voltage of this 5 volts up to 12 volts and then convert it out into AC. However, this only outputs 220 volts AC, and I just don't want to be messing about that kind of voltage, yeah, no thank you. So I need another solution. Now I do, like I said, have this one, which again, you know, I don't really want to be messing about with it, but it can be used, if I can understand it correctly, to produce 18 volts AC. So I'm thinking, I really don't know. I don't know. I'd like to be able to disable the rest of it, but yeah, I don't know if I'm gonna be able to. Apparently this can just produce 18 volts here. Yeah, if I can get 18 volts out of this, I wouldn't really mind. So maybe this might be a solution. Let's just quickly check the description for this one. So the input voltage DC is 12 volts or 24 volts, and the output is anywhere from 0 to 220 volts to 380 volts, and AC 18 volts. Output frequency is 20 kilohertz. I'm a bit scared to use it. But anyway, so okay, let's say I do go ahead and use this. I don't know why it's all the things are all bent. Let's say I do go ahead and use this, right? I would be using the 18 volts, which is these two at the end here, so V6 and V7. Now I would need to put, was it 12 volts minimum into this, right? So I do have a boost converter. Shout out to IC Station. They're the ones who sent me the Bluetooth speaker kit. As part of that, what I asked for was a heart rate sensor module, which is this one here. They sent that to me as well, so shout out to them. I need to do a video on that. But they also just included this boost converter, which is perfect because I was literally just about to buy one. So you see the IC Station. So let me take out this boost converter. Cool. So what I could do is I could use this boost converter here to increase this 5 volts up to 12 volts. So I'll place that, you know, and then place this there. So you have the charge controller into the boost converter, the 5 volts, and then increase that to 12 volts. Maybe that way actually. Increase that to 12 volts and then put the 12 volts into here and then get 18 volts from there. So I just don't want to be messing about with 220 or 360 volts, right? I don't want to stick my multimeter into something and it blow up my multimeter and end up sparks. So this is scary stuff. Okay, so I do actually feel a lot better. I've watched a few YouTube videos, and one thing I could say is that I now know I need to connect the VCC input to this point here, basically. So, you know, grab some wire and solder it into that hole there. Again, do the same up here for the ground, and you can see that on the PCB on the other side, where you've got VCC plus, which is there, and VCC minus or ground there. So actually what that's going to be is that's going to be my output of my boost converter. So the V out positive is going to go to here. I could solder it onto the top obviously, but we'll solder it onto the bottom there, which is what I saw the guy do on a YouTube video. And then again VCC minus to over to here. Now interestingly, you've got a switch here, these two solderable points there, which is KSW. There you go, KSW there. So that's actually a switch to turn it on and off. So I'm going to solder some wire onto there as well, 2 individual wires, and then connect them together in order to turn this on, which is great because I can just disconnect them and then this whole thing turns off, which is nice. Could actually just solder on, just straight solder on a switch, which I might do. And then yeah, I just need to just take my output from V6 and V7, which would be 18 volts. And I think that's it. Should we give it a go? I must say I'm a bit scared. I might sleep on it. Very interesting is that even when I disconnect the solar panel and I've just left the battery connected, if I check that 5 volt rail, we've still got 5.11 volts. So that's how you know this charge controller is working very well. Interestingly, let's turn on the solar panel and let's disconnect the battery. And now let's see if we still get that 5 volts. No, we don't. Interesting. Okay, that's good to know. I think the next stage now, I haven't slept on this yet. Need to get back to that. But I think the next stage now is just to connect the 5 volt rail. So if I connect the positive rail here, negative there, and then wire that into this boost converter, then we should be able to boost the voltage up. Okay, so I've set it up. I've attached the charge controller and the boost converter. So I've got V plus V minus coming into the input there. You can see there, soldered it in. And so let's check the voltage. God dang, 29 volts. Okay. Well, yeah, that's not cool. We need that much lower. So I'm just gonna spin this potentiometer to the right. Okay, let's check it now. 8 volts. So we need to go back to the left. We want it at 12.35. Okay, that's fine. So we'll go with 12.35. So we've got 12.35 volts there. Now, what I wanted to mention is about this thing here, this inverter. It says it can take 12 to 24 volts input, right? That's what it says. Now, this capacitor here clearly says 16 volts. So I don't think this is going to be a good idea sticking 24 volts into this, which this just gives me no trust about this this listing, sadly. So we're going to connect this boost converter's output of 12 volts to the input here. We've got VCC there and ground there, so we're going to connect it to the underneath, and we're also going to attach a switch to these 2 wires here. Should be fairly simple to do, to be honest with you. It's just a bit scary, that's all. Alright, so I've made some progress. So I've soldered on 2 wires here for this switch, which you can see in there, these 2 points here. I've also soldered on the positive supply, a nice long lead onto the positive end, and then same to the negative end at the bottom as well. So that should sit like that, no problems. And then when I want to turn it on, I just need to just touch these 2 switches together, these 2 wires together, to close the switch and then turn it on. I just got to attach positive and negative of these to here, and then nothing should happen once I attach them. So I'm just going to solder them on now, and then once I close this switch, I should be able to test at these points here for certain voltages. So I'm hoping I can just put my probe onto V6 or V7, hopefully just read 18 volts, and then boom, we're done. That's the plan, and then maybe we can check it on an oscilloscope. Alright, so this is the moment where I wish I slept on it. So I've got my battery connected to the solar charger, which is going to this boost converter, and then it's now currently being directly connected straight to this inverter, which is scary. So let me just check the voltage. I don't even have the solar panel on right now. 12.46 volts. Alright, any volts at V6 and V7. So no voltage here right now. I don't even want to have to actually hold that to connect those 2 cables together. Ugh. So apparently as soon as I close them, it should turn on. The worst that could happen is quite bad, right? So let's just hope for the best. Okay, I saw an LED turn on there. There we go, LED's on, and I can hear the inverter. That scares the crap out of me. Well, nothing exploded, which is good. It's just beyond my pay grade to be messing with inverters. So it's nice that they got an LED there and you can hear the audible sound as well. Alright, so here's what's even scarier. So I just connected the 2 wires just using a jumper cable, which I thought, you know what, I'll just cut it if anything goes wrong. Just cut the cable. Okay, so here's what's scary. When I connected it, the LED turned on for about 5 seconds, and the boost converter is not connected at all to the solar charge controller. So what that tells me is that this bloody inverter is holding voltage. Sorry, this capacitor, this giant capacitor is holding voltage. So I need to be very careful there. I've just drained it, obviously, by, you know, shorting these 2 together, and then the LED is drained, but just something I need to be wary of. So now I'm going to connect the inverter back on, and you can hear it's turned on there. Okay, so hopefully we can get 18 volts. So I'll put it onto the AC setting, and then, whoa. Okay, I think maybe my battery might be draining. Let me turn on the solar panel. Oh, the LED's turned off. Okay, there's no voltage. Let me check the voltage at my battery. 2.9 volts. So, okay, my battery's charging slowly now from the solar panel. But it seems like this inverter completely drained my battery. That's crazy. Wow. My battery went bloop. So what's my solar panel producing right now? 4.84 volts. So we got a good voltage at the solar panel. Do we have our voltage at our boost converter? No, we don't. Interesting. Okay, so we don't have. All right, interesting. So the solar panel the solar charge controller is actually disconnected its 5-volt output. I'm assuming because it's charging up the battery right now. So the battery is currently 3 volts. It's charging quite fast. Okay. Well, let's leave this here and see when the inverter turns back on. This is fascinating. So it has to do with the battery voltage. Looks like this inverter is not going to run for very long. So I need another solution, basically. This isn't going to work. Probably need a much smaller AC inverter. This one produced, what was it again? It was 12 volts in. It might have produced only 12 volts out. No, actually, no. This one produces just straight 220 volts, which I don't want to deal with. But it's a lot smaller. I could try this one, but I really don't want to mess with 220 volts. I think I might order another, try and look for another inverter. I actually struggled to find decent inverters actually to purchase, so this may be harder than it seems. Alright, so I'm going to try this again. However, I actually have a new idea, which I'll go through in a minute, but let's just try this again. I've had this, the panel charging for quite a long time now. Actually, over a day, and it won't go above the 3.3 volts. Let's just have a look. So I'm not sure what's causing it to not charge fully. It should go at least up to 3.7 volts, if not way higher, to 4.2. So let's just check it here. There we go. 3.2, there you go, 3.26. So that's not going to be enough to run this large AC inverter, and that's fine. I mean, this AC inverter here is too big anyways. But I mean, the way that we would know actually is we're not going to get our 5 volts from this anyways. So if I check here, you can see that we've got no voltage at these pins, the 5 volt output pin. So, and actually you can see from there that there is no on LED. That's normally on when the battery is fully charged. So I don't know what to do in that sense. But now the alternative is to just scrap this one, and you know the other inverter that I have. So this one, I watched a YouTube video of it, which hopefully I'll remember to link it below. If not, can one of you guys remind me? Basically, the guy, he reviewed this 5 years ago. So what he did was he supplied 0.6 volts. So basically nothing, right? This should need 12 volts. So you put 12 volts in and you get 220 volts AC out. That's what this is supposed to do. He put 0.6 in and he got 8 volts out. So I'm hoping if I can put 0.7, 0.8 volts in, I might be able to get a low AC voltage out of 12 volts. I'm not sure if it's going to be a pure sine wave. We can check that on the oscilloscope. But let me try by putting in a small voltage into here. I suppose the question is there now, how do I get this small voltage out from here? Once we can get 5 volt solid from here again, then I need to drop the voltage, which I don't have a buck converter. I've only got this boost converter, which I used for the big inverter. So I think I need to drop the voltage manually, probably using resistors. I don't even know how to do that, to be honest with you. That actually sounds complicated, but let's just give it a go, you know. I just got to drop the voltage down to as low as possible. I mean, this is 5 volts, so we can just test. By putting 5 volts into here, what do we get out? Maybe that's a good shout to do, actually, yeah. Yeah, let's do that. Okay, so let's try this out. So we're going to try, I've got my power supply here. So let's start, if we start with 1 volt. Okay, so let's see if it works. I've got just these wires soldered in here. So if we go positive supply, which I believe is, no, I've done my colors one way around. Red, blue, so red is the ground. Now let's use our multimeter to check what we're getting AC on the output. So it says 0.59 volts at the output. I mean, am I reading the right output here? That's got to be it, right? 0.5 volts. I don't know what's happening there, but it's saying 58 volts, so I'm not sure. It's jumping around, but I saw it jump to 58 volts there, so. Okay, my multimeter is not happy about something. It doesn't like it. It's beeping and saying oh. And then look, it like spikes to like 45 volts. Let me just turn it up. So we're currently at 8 volts. Hopefully my multimeter doesn't die. I actually really like this multimeter, but I don't know why it's telling me off. Oh well, and then it's like, was that 106 volts? Yeah, that says 106 volts. Maybe I need my oscilloscope, but I really don't want to use the oscilloscope on this. I just don't trust it. That's not going to blow it up. So if I go up to 12 volts. Alright, let's hope for the best now. It literally just turned off. Okay, well, it turned back on. Okay, so 2.4 volts. And then what I'm going to do is I'm going to try it out on my cheap oscilloscope. So that way if I fry it, then, you know, it's hopefully it's only £50 lost and not freaking 200 quid on my main oscilloscope. So we'll use that one. Let's try and see if we can get some reading, man. I mean, okay, so if I'm going to destroy my oscilloscope, which is sad. I really like this oscilloscope. I mean, can we just go low voltage? Okay. Oh, yeah. Please don't die on me, little man. Come on, oscilloscope. We got this. I think it will be okay. Ready? 0.7 volts. Okay, so if I press auto, and right now we just got some noise. Okay, crank it up a bit. 1.1 volts. Okay, so apparently 42 millivolts. Okay, 4 volts, we're seeing something. Okay. We did it. Let me just zoom in. There we go. We actually have a sine wave of 6.6 volts. So 4 volts was producing about 6 volts. 3.4 volts. Gonna go down lower. 2.8 volts. I'd like to see at what point we no longer get a sine wave. Alright, so here we've got 3.1 volts, 2.8 volts coming in here. This is brilliant. So we've got 2.8 volts DC and we're getting 3.1 volts AC 37 kilohertz. This is it. I think this little thing does it. Okay, how low can we go? Alright, so 1.1 volts. There's nothing there. 1.2, 1.3, 1. I want it as low as possible. 1.5, 1.7, 1.9, 2 volts. Okay, there you go. So 3.6, we got something. Let's go down. 3 volts. Okay, so it's working at 3 volts. It's weird. There seems to be like a strange cutoff. But even at 2.2 volts, it's still working. Oh, there we go. 2 volts. It's there. You can see it as the sine wave gets smaller. Okay, it's still there. Well, 1.9, it's still there. Okay, 1.4 is just gone. Can it come back at 1.9? See, look, it won't come back at 1.9. So I think once it starts working, you need to get it to start working and then go low. Okay, so let me go with 5 volts. If we can get 5 volts AC out of this, I'll be happy with that. So let's make it. So at 4 volts, we're getting 6 volts. Okay. Let me just go higher. Let's see what we can do. Push it. What can we push it to? So 5.5 volts is producing 7.7. Okay, 6 volts is 8.5 volts. So 9.5 volts is producing 14.5. 10 volts is 15. I'm intrigued here because I've got it on 1x and my thing's on 1x. I'm just checking my oscilloscope settings are correct because I would have thought 10 volts would have been producing a lot higher voltage than that. So we're getting 20 volts right now from 11.3. I thought 12 volts would have done 220. We've got a very badly distorted sine wave now. Okay, so I've just pressed my 10x probe and it's now saying 92 volts, 177 volts. And that actually seems more correct to me. So I'm just wondering, I mean, I've literally, look, I've got my probe set to the 1x. I've got my probe set to the 1x. But this is supposed to take in 12 volts and output 220 volts. So I expected higher. So I'm actually thinking maybe I've done it wrong. So let me switch this on to 10x. Okay, alright, interesting. So the voltage has actually dropped to 47.5. So actually, I think my previous measurements were incorrect, actually. Let's go back again. Let's start over. If we go down to 1 volt, okay? So at 1 volt, we don't have anything. There's nothing. Or it's actually dropped to below 1 volt. There, 1 volt, we've got nothing. Let's just go zoom in a little bit, see if we can see something. No, okay. So at 1.3 volts, at 2 volts, nothing. 2.8 volts, nothing. 3 volts, still nothing. Interesting. Yeah. Okay, there we go. So at 3.6 volts, it's giving us 35 volts AC. Damn. And that actually seems correct to me. Let me see if I can try with my multimeter now. So we've got 3.6 volts giving us 35 volts. Okay, let's keep going up. So 4.3 gives us 47 volts. 5 volts gives us 55 volts. I think that's that. You know, I don't want that kind of high voltage coming out of my kit. So I wonder what it would be a safe low voltage AC, for example, to short out, because you can imagine someone accidentally shorting out the output. So let me quickly Google that. What would be a safe AC output? I'm gonna guess, you know, about 12 volts would be safe to short out. Let me quickly check. Okay, so I've had a look, and apparently no voltage basically is safe. Obviously, it depends upon the current. So I need to keep that in mind and do something to make sure that I need to have some sort of short circuit voltage protection. So I've got a list which I'm building, which is like legal considerations, and I think that's got to be one of them. That if I am gonna have any sort of inverter or something produce an AC output, I'm gonna have to figure out a way to keep it safe. Just assume, you know, like that someone's gonna short out the output. If they do short the output, then what am I gonna do to make sure that something happens and not to them? So what I did see was that basically anything above, some websites said 50 volts, anything above 50 volts, so here we got, is unsafe, which is scary for me right now. And then some said anything above 30 volts AC is completely unsafe as well. Some said 20 volts, and the majority said, look, 12 volts AC is fine, generally speaking. Most of the time, those kind of circuits aren't going to have high current. So let's see if I can get 12 volts AC out of this. It might be a bit tricky. We'll see. Oh, yep. Looks like I'm going there. Okay, so it cut off there. Let's just go. What's the on voltage to turn this circuit on? So 3.2 volts. Look, it's not even turning on, which is concerning. There we go. So it turned on at 3.9 volts. Maybe I could use something to maybe drop the voltage at the output. So 40 volts, 3.9. Because look, once it's turned on, then you could turn the voltage down, for example, to 2 volts there, and the circuit stays on, and you can see 15 volts here, and then it'll cut off 12.5 volts at 1.7 volts, which is nice. 1.5 volts, 10 volts, nice. So you see, once it's on, there you go, it cut off. It cut off going to 1.4 basically. It didn't even get to 1. I didn't even take it down to 1.4 and it cut off. So look, so it's off now, and then if I crank it up to 2.5, it still won't turn on. So it turns on at what, 3 volts? 3.6, it seems like it's turned it back off again. I want to see if it turns on at 3 volts. Three 3.3 volts still not on, so if it turns on at 3.5, no? So above 3.5, it turns on. And at that on voltage is 38. So it looks like I'm going to have to leave it at this. So if I can basically have the output of the solar charge controller, which, let me get that. So if I have the output of this, which is 5 volts, and drop it down to 3.7 basically. So this is the 5 volt output here, the USB and this red 5 volt pin there. So if I can drop that down to 3.7 volts somehow, maybe have like a little breadboard resistor circuit to take some voltage. If not, what's the voltage at 5 volts? 57 volts. Yeah, okay. Alright, I'm going to make a circuit to drop the voltage. I'm not even sure how I'll do that, to be honest. I'm guessing I just use resistors. Yeah, 5 volts. 55 volts is too high for me. Way too high for me. Okay, so here's the current plan. We've got 5 volts going into the solar panel, which is then going into the charge controller, which charges the battery. The battery is then going to output a solid 5 volts via the charge controller here, and then we need a circuitry in between here at this 5 volt output to go into this inverter to then output 12 volts AC. So we're gonna go 5 volts solar, which is actually, you know, if you think about it, it's just amazing how you got 5 volts, you know, of free energy, 5 volts into here, which then goes down to 3.7 volts into this battery, but also outputs 5 volts here into this inverter, which then outputs 12 volt AC. Like, I'm actually mind blown already just from that. It's fantastic. It's electronics is brilliant. It's absolutely brilliant. So I think what we'll do from here is let's connect this circuit up. Let's get the 5 volts into this battery, and let's see if we can just power this inverter from the battery and see if we can get, so the 5 volts connected directly to this inverter is going to produce, I think, about 50 volts. Could be a bit dangerous for me. I hope not, but let's try it. And then what I'll do is, if that works correctly, then I'll figure out a circuitry to drop the voltage a little bit in between here. So let's do that. Okay, so I've got everything set up, and we can see clearly, actually, if we check over here, that the voltage, let's check, voltage on the panel input is 4.4 volts. Voltage to the battery is 4.2 volts. Can you see that? Yep. And then now if we do ground to the 5 volt pin, we've got ground and 5 volt pin. There we go. We've got 5.11 volts. It's just amazing, you know, 4.4 volts, 4.2 volts, 5.11 volts. Fantastic. I'm absolutely loving this. So let's now connect these 5 volt pin, this 5 volt pin to this 5 volt input and check the output. Okay, so I'd be lying if I said I wasn't a little bit concerned, but let's put our negative rail here. And then so we're going to get positive into here. And then now we're going to have 50 something volts on the end here, which is, okay. It's so scary that, you know, you just put 50, there's now 50 volts there and you can't hear anything. It's concerning. So let me disconnect this, and I think I'll stick the oscilloscope on the end so we can at least confirm that we are getting 50 something volts at the end there. Alright, so moment of truth. We've got the oscilloscope set up. Let's just connect in our last. Hey, we got a straight voltage right there, and it's coming up as, crap man, 160 volts. Okay. Why is it 160 volts? So 150 volts. Yikes. I don't know why. I don't know why it's so much. I want to take a look at the input voltage. Yeah, so the input voltage is 5.1 volts. But yet for some reason at the output, I don't think I'm even going to be able to read it. Yeah, my multimeter doesn't want it. I don't understand why. Literally, my multimeter there says max 600 volts. So I don't see what its problem is. It doesn't like this 152 volts. Well, this is strange, right? Because why am I getting 150 volts? That's nuts, isn't it? That this little thing is whacking out 150 volts AC. I'm not sure what to do at this point. I think what I might do now is, because I really don't want to mess about with 150 volts. I mean, even if I make a secondary circuit, right, on a breadboard, I'm still generating 150 volts, and I'm putting it into an extra breadboard to drop the voltage down. And in reality, I don't want it. I mean, maybe actually one thing I could do is maybe I could drop this 5 volts. Actually, let's try that. Okay, I'll make a circuit here where I'm dropping the voltage, the 5 volts down to the 3.5 volts. I think it needs to. I mean, it should just be simple. I should just be able to put a bunch of resistors in series, or just a high resistor. But yeah, let me try to put a circuitry on the input into the inverter and hopefully drop this voltage down. Let's try that. Okay, so have a look what I've done. So I've got the whole setup, everything connected except the 5 volts from the solar charger into the inverter. Now, if I just connect them two together and send the 5 volts in, then okay, let's just close this together. So what you're gonna see is you get 180 volts, or if I let go of it, 180, 170 volts. Now, if I do the same thing, but this time I put a diode between them and do it the right way around. The diode obviously has a voltage drop, so what it does is the diode drops the voltage from 180 down to 150. Obviously the diode isn't dropping 30 volts. What the diode is doing is actually dropping the 5 volts down to 4.3 volts into the inverter. So if I put two of these in series, then I should be able to get, I'm still not going to be significantly lower, but you know, at least a lot more voltage on the output. So let me try and add some more diodes and see what I can do. Okay, so what I've done is I've connected up 3 diodes here, just in series. And so when I connect them now into the circuit, so got this yellow, so just putting them again between the solar charger and the inverter. Okay, so I'm not actually getting, okay, hang on. So I think that drops the voltage too much, because you can see here that it's working by itself. So let me just try 2. There you go. So 2 works fine. 2 drops the voltage down to 115 volts, which again, yeah, is still, and it's actually clipping it as well. But look at that, that's not a sine wave at all anymore, is it? Whilst if I remove it, alright, and then that's a much better sine wave, right? I mean, it's still a little bit dodgy, isn't it? But 190 volts. So we're taking 190 volts right now, and we're knocking that down to 120. I think this is the best I'm going to be able to do using commercial parts, except if I could drop the voltage down at this output end. So I think what I'll do is I'll wrap this video up here, because you know, technically I have a working AC output, and that's what I wanted. And so this has been, you know, quite a challenging video, and a lot's been done in this video. And I think what I'll do in the next video is I actually have one of these like sine wave generators. And so, you know, I mean, the AC output, right, is just a sine wave. So it's obviously not going to be a pure sine wave. But I mean, is this really a pure sine wave? So I'm thinking in the next video, I'll use this to create you know, a sine wave. This is just a function generator, right? So I'm hoping if I use this to create a sine wave, then maybe I can just have like a 10 volt, 12 volt sine wave. That's what I'm thinking. So maybe, for example, instead of having an inverter which creates a true AC output, maybe I could create, just basically have like a mini sine wave generator, function generator from the DC output of the solar charger. That might be the best solution. But yeah, we'll do that in the next video. So thanks for watching, guys. I appreciate it. This is obviously tough. It is tough. I mean, at times I'm really rattling my brain and pretty much guesswork, which is a shame. But along that process, I'm learning a bunch. And so, you know, I'm feeling confident. I'm really glad, really glad that I'm going through this in the summertime. And I would just advise you, you know, if you are in your second year and you're in summertime now, start. And if you're in your, you know, first year, anyways, whatever year you're in, utilize your summer, utilize those breaks. Obviously, if you're burnt out and you need a break, then take a break. I'm loving this. I'm not burnt out in any way, shape, or form. You know, I was burnt out from some of my modules that I was studying, but this stuff fascinates me. And the fact that I'm going to be designing, like, if I can build my own kind of inverter thing, like, there's surely something in here which is creating like the super high AC output. There's got to be something, right? And so I've just got to figure out what it is and adjust it. You know, is it the capacitor? I already know that, for example, this capacitor at the output is smoothing out the output. So what is it about this that is generating such a high voltage? Is it the coil? You know, what on this can I replace? I mean, I'm not gonna find a YouTube video where someone's modifying this to reduce the output, and I wish I could, but unfortunately it's not going to be there. And if it is, it's going to be buried in the archive somewhere, because it's just one of those ones where it's like I need some experts in here. Unfortunately, I don't have access to any. I mean, obviously I paid $9.5 grand for uni, but can I just email my lecturers and say, hey, how do I reduce this output? Yeah. Anyways, cool, guys. I'll see you in the next one. Thanks for watching. I look forward to the next one. this should be good.